Hello guys, let's start solving this Leetcode challenge 2071 which was asked in Google. So these are the tasks given to us and these are the workers, pills and sprints. We have to find the maximum tasks we can assign to workers, and condition is also given to us that workers can be assigned to at max one task or zero. So this we have to keep in mind. Brute force approach. We would try every possible combination of assigning tasks to workers and permute. For that, we would need to permute tasks and match with workers, track the maximum number of successful assignments in each operation. Like here, it would be I would take this pill here at zero. So still, it would be able to solve this task. This one can do this task, this one can do this task. So we would get 2 as the answer here. But when doing the permutation and choosing this and this combination, we get 3. 0, this would take a pill, become 1, solve this, 3, solve 2, 3, solve 3. So we would get our answer as 3 tasks done, which is the maximum task possible as each worker can do 1 task. So that would be our answer. Time complexity here would be n factorial because we are taking permutations of the tasks array. So not feasible for large inputs. Let's go towards the better approach. Here, this is the task array and this is the workers array. Same example we are taking. So now that we know that normal brute force won't work, so we have to find an optimal one. So we would think of sorting the tasks in the ascending order and count and sort workers also in ascending order. We could have 3 cases here. Both ascending, this descending, this descending, this ascending, or both descending. So we would try to ascend both and count the assignments possible. We would take this example too and see how it works. For the as I have sorted in ascending order, 1 plus 6 the strength would solve this 5, but this 2 cannot solve the next task, and same goes for others. They won't be able to solve. So only one task get resolved. Now let's reverse this, sort in reverse order, and this is ascending order, and check if now we get the maximum task. 6 will solve 5, 6 will solve 5, 4 with the pill will solve 7. These two would remain unresolved. So the task's completion would be 3 here. So you can see that sorting workers in descending order is right. We can also think of this logically, like we are choosing the minimum tasks. To do those tasks, we are choosing the workers with maximum strength. So obviously, this would be the most optimal possibility, which would give us maximum count. Now, why binary search? Why are we applying binary search to this question? Range in which possible tasks can lie here is 0 to minimum of the tasks and workers, as each worker can only be assigned to 0 or 1 task. So 0, 1, 2, 3, 4, 5 would be the possible range in this example. Instead of checking every value in this range one by one, if 0 tasks are possible, 1 tasks are possible, I would do binary search on this answer as an optimization, which would be done quickly. Log n time only it would take, not O n time like in the linear search. So left would be 0. This is the answer range. And right would be 5 for this example. Mid value I'll calculate as 2. Check, and now I would check if at least 2 tasks are possible out of how I sorted tasks in ascending order and workers in descending order. 5, 5, 6, 6. This 6 will solve this 5. I would iterate over these tasks backward. Because if the maximum strength worker here can solve the maximum strength task here, the previous values will also be able to solve. Previous less strength values would get to solve less concentrated tasks. So there is a high chance we can get max count from there also. Left Now that we got the mid value, 2 tasks are completed. We can we would go ahead, we would move our left pointer to 3 as we want maximum count for this out of this range. So we would check if our luck is good and we can get 3 count. Mid value would be 5 plus 3, 8, divided by 2, 4. So let's see if I can get 4 tasks completed choosing these 4 ascending, descending, going from here. The first task can't be completed. I would take a pill and then it can get completed as pill strength is 6. So this task is done. Now I'm here. Again, this task cannot be done. So my answer is 1 here. Now that this is overcompensating and I cannot move towards any further here, I would try to reduce my right pointer to mid minus 1, should get me 3. Now my left is at 3, right is at 3. Mid value would be 3. So now I'm taking these first 3 values, checking from here again. This 6 will eat the pill, solve this one. This 6 will also solve this one, but this 4 cannot solve this 5. We are getting the 2 as answer. But 2 would not be the maximum here. From this portion, we can identify that we need a multi-set to solve this question. Let's see how. Non-pill help worker, best case scene. If the worker does not need a pill to complete a task, the best case scenario would be the greater task getting completed by this, which was not the case here. Pill help worker. Now, if I need to take a pill, no worker can solve this huge 7 without the help of pill. So, if I need to take a pill, the best case scenario would be smallest worker doing largest task with pill. So I would choose the smallest worker, take the pill, and see if that worker can solve this problem so that the workers with great strength are remaining for the tasks with less power required. This is what being greedy is here, as we saw previously too. So we need a lower bound. If we need a pill, without pill we cannot solve the question. We need to do the lower bound, which was 7. The greatest task was 7 required, and the strength of pill was 6. So 1 is my lower bound. So I would sort the elements of the workers into a multi-set, and this is why we are using multi-set. Ascending sorted order, duplicates are also included. So this would be our ascending multi-set. First value is 4, lower bound is 1. So I'm gonna take this out, add the strength to it, and this task would get completed because of that. Now, for this 6, I would again check this value because these are normal, these don't require pills to solve. So I'm gonna take them out from the right side. As we saw earlier too, the greater strength the worker has, the we try to go from right side. Multiset uses log n for insertion and deletion. So time complexity would be this is for sorting, this is for sorting, this is for multiset. An optimal approach would be instead of multiset, we can use DQ also. It would take O1 time to pop left as well as pop right. Everything else remains same. So our time complexity would become this. This is the most optimal approach. So the summary was we have to take easiest task. So we would sort tasks in ascending order, workers in descending order because higher strength workers should get matched with lower set of tasks so that everything will be possible at a max count. Multiset we are using to store this k workers at max. Mid This mid value was from the binary search. This is the maximum possible we are checking for tasks. So strongest worker, strongest task. So all the weak tasks would be left for weaker workers. If not without pill, if you cannot solve any task without pill, would use the lower bound concept and use pill on the weakest worker so that the other workers can handle the values less than that because that biggest value cannot be solved by any worker. So if that value is not solvable, we could only think of the other small values can only be solved with workers greater than the weakest worker. That is why we need to eliminate this worker for maximum. So that was it. Thank you. Please like and subscribe to my channel. It took a really long time to record this video and research about topics. And please, the link, the link to the solution codes for in different languages is in the description. You can check it out from there. Okay, see you tomorrow. Bye bye.